So we are looking, it said our instructions said that we're supposed to solve the equation, and we had started getting into these ones where we started with what yesterday? We started super simple, right? Or just sine x and it equals a number. It should be 3 pages. Okay, total. And then and we said that's kind of the last line of the work. Then we got to these ones where we had to do a little bit of solving. We treated the trig like it was a variable. And then we had to manipulate the trig a little bit more. We had to combine some like terms. And then finally we got to these ones where, we had to start factoring, okay, to solve it. So we did some greatest common factor with the 2 we did with the factoring yesterday. So now we're going to move on to other types of factoring, which we did see this part last week. We just need to make sure we refresh our memory and actually solve this time, okay? So let's see. I'm going to skim really quick what we got here. Oh, yeah, we have to do... Okay, so we're not going to do example 16. Okay, so if you need the extra space, we're going to cross out 16. Okay, it's the exact same problem as 15. It just has cosine instead of sine. If we can do 15, we can do 16. Okay, all right. What I would do is use the same technique we had last week, where I would pretend the signs are x's. That puts us into a comfort zone that we're a little bit happier with. So 2x squared minus x minus 1 equals 0. That's what we want to think about it like. Okay. So if I'm going to solve this, what am I going to use to solve that? Think factoring. What do we have to do? Magic X. Okay, so we're going to do a good old magic X. All right. Remember, to get the top of the magic X, we multiply the first and the third together. So what is 2 times negative 1? Negative 2. Good. And then the bottom is this negative 1 that's there in the middle. So what 2 numbers multiply to negative 2 and add to negative 1? Everybody go negative 2, positive 1. Okay, do I need a box?
No. Oh, yes.
Okay, there's a leading coefficient. We have to have a box, so we're going to get out the box. Okay, top left-hand corner of the box is going to be 2x squared. Bottom right is going to be the negative 1. And then we're going to use the numbers from the magic X and put them in the other 2 spots. Does not matter the order. Okay. All right. What times what is 2? 2 and 1. Where's my 2 got to go according to my box? On the left side. Good. So next year when you come in, guess what I do? I say factor it and I don't go over it. Okay. So you have to have this down. Okay. Factor it in unit circle. If you can walk in with those 2 things in the fall, we're looking really good. Okay. All right. And there's got to be 1x on the top. How many times does 2x divide negative 2x? Negative 1. Okay, what times x is 1x? 1, and then 1 times negative 1 is negative 1. So it checked out, okay? Now, when I go write this down, actually, well, I'll write it the way it looks. So it's like saying that we had 2x minus 1 times x minus 1 equals 0. But that wasn't the problem we were trying to solve, right? What do we need to replace those x's with now? Sine, okay? So we've got 2 sine x minus 1 times sine x minus 1 equals 0. All right. What property do I need to apply? What's it called? Good. Zero product property. Okay, so we're going to do zero product property, which means I'm going to split them both up and set them equal to 0. You're welcome. All right. So 2 sine x minus 1 equals 0 and sine x minus 1 equals 0. All right. What am I going to do with this one? Bring it to the other side by adding it. Probably going too fast, sorry. I'll let you catch up. Okay. I have a 2 hanging out in front, so what am I going to do to move that 2 to the other side? Good. So sine x equals 1/2. All right. Unit circle time, right? That's the new, addition to this. All right, so assign the x value or the y value. Y value. Okay, so I'm not even gonna go do I'm gonna let you do the unit circle work because I know you all can do it at this point. All right, so go find everywhere where the y value is equal to 1/2. Write it down. Don't yell it out yet. Write it down. Okay, what are we getting? Pi over 6 and 5 pi over 6. But we're not done yet, right? So we still have that other branch of the factoring there, the zero product property. So I got to take this 1 and move it to the other side. So sine x equals 1. All right, I now need to look for where the y value is equal to positive 1 only. So go around your unit circle and look. So everybody's looking on their unit circle. All right, where'd you find it? Good. So this one only had 3 answers. Yesterday we saw some with 2 answers, some with 4 answers. This one's got 3. Okay. So I can't just say you're always going to have 4. You're always going to have 2. It varies. Okay. All right. Let's take a look at this next one here, which I think you might be able to do. Oh, we're going to start it together. Okay. And then we're going to have you work on finishing it. All right. Everybody go with 15. Can I move it? Okay. Let's take a look at 17. And we're going to do the same thing. We're going to get rid of 18 and use the space for it. They're identical problems, except for I swapped out secant and tangent. I've swapped in different things, different pieces of trig, but same technique. Okay. So we have that 2 sine squared x plus 3 cosine x minus 3 equals 0. The problem we have here is that in order to factor, it has to be the same piece of trig. When we factored with x's, it had to be all x's, right? So this one, we can't have a sine and a cosine. So I need to find a way to substitute for one of them, okay? I can't really substitute much in for cosine other than 1 over secant, right? That's all I can put in for that. So that really doesn't help us. So I would look at the sine. And probably we're going to look at the Pythagorean identities because whenever we see squared, we're going to look at the pink Pythagorean identities. So look up at the pink sign. Okay. It's on both sides of the room. I know you all know where it is because I watched you looking at it on the quiz. Okay. All right. And if you notice, we have that line that says sine squared plus cosine squared equals 1, right? I want to get it so it just says sine squared. Okay. So you can read it literally off the sign. Or I could subtract this to the other side, right? So I know that sine squared equals 1 minus cosine squared. It's the, what is it? The top row, last column, right? Is the formula that we're using. Remember that each row is the same equation. It's just I rewrote it different ways, okay? All right, so I'm taking this and I'm substituting it in. So 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. All right, we're going to do a little bit of algebra before we can factor, okay? What do you think I'm going to do next? Yeah, distribute the 2. That instinct should kick in and do that. So 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. All right, what's next? Can't factor it yet. There's something else I can do. Are there any like terms? Yeah, can't I put these guys together? So what's 2 minus 3? Good. Cosine squared x plus 3 cosine x minus 1, right? I'm just going to write the 3. Equals 0. It looks very similar now to what we did in the last problem. It's a trinomial with a leading coefficient. We should be able to factor. There's one other little tweak I'm going to make before we have you factor it, okay? It's leading coefficients are a pain, but negative leading coefficients are worse, okay? So if I can get rid of the negative lead, I want to do that, okay? Technically, I'm going to divide everything by -1, but isn't that the same thing as just switching all the signs? Okay, so we're just going to switch all the signs, okay? So plus, this is going to be minus, this one's going to be plus. Technically, that would be minus, but 0 is 0, right? So just going to stay the way it is. All right, here's what I want you to do. Now you're going to practice the skill we learned in the last one, okay? So you're going to do your magic X. You got a lead coefficient, so you need a box. So try to put them into X's, right? So make your cosines X's, and go ahead and take a couple minutes and try to factor that on your own. Give you about another 30 to 45 seconds. I know we were working hard on it. Yeah. Okay, I want you to talk about it with your table first. Okay, and then we'll talk about it together. So everybody have a small conversation, compare your work. Okay, compare your answers. Okay, let's take a look at it together. Make sure everybody's got all the steps. Okay, we've got it right. So I have my magic X set up. I needed two numbers that multiplied to 2 and added to -3. What are they? Okay, so I've got a -2 here, -1 there. Okay, what times what was 2 in the box? 2 and 1. It's not a hard question, right? All right, so 2 and 1. Where's my 2 got to go? Left side according to my box. What times 2x is -2x? And what times 1x is -1x? -1 times -1. 1. So I have x minus 1 times 2x minus 1 equals 0. You don't have to write those two things down. If it helps you to figure it out, write it down. Okay? But it's not required if you can understand it with all the trig. Okay? And that's either way is fine. Okay? So what am I gonna replace my x's with? Cosine. So cosine x minus 1 times 2 cosine x minus 1 equals 0. All right, what property do we need?
0.
Good. So cosine x minus 1 equals 0 and 2 cosine x minus 1 equals 0. So what, and this one here, what am I going to do with the 1? What are we going to do with the 1, guys? Add it. Okay. Let's cosine the x value or the y value? X value. So did we... no, that's not 17. What was the radian measure that you got for the x value at 1? I heard 2 pi, right? Okay, but here's the catch. Remember this guy up here? Let's talk domain. Does that mean that do I get to use 2 pi because of that parentheses? No. Technically, 2 pi is not included. What is included that's the same as 2 pi? 0. So my answer should be 0. Okay? 2 pi is the good wrong answer. All right? So make that adjustment. Okay? All right. What am I going to do with this 1 right here? How do I move it? Add it over. So 2 cosine x equals 1. And then what am I going to do with the 2? Good. All right. So cosine is the x value. Where on the unit circle is the x value equal to 1/2? Everybody good with that? Pi over 3, 5 pi over 3. Okay. All right. We're going to keep making it. We're going to make it, I think, one more that's a little bit harder. Okay. And then we got to change it up just a little bit. There's another step we have to add into this. Okay. Let's get rid of 20. It's Friday. Look at all these ones we're skipping on Friday. How nice is that? Okay. All right. I should just take them out, but then next year they wouldn't feel like I'm skipping anything, right? So I should just leave them out. All right. Looking at example 19, we've got cosine x plus 1 equals sine x. We're still on the domain. Oh, yeah, we're still on the domain 0 to 2 pi. So the tricky thing about this one is there's not a whole lot I can do with it to replace sine and cosine. Okay. So I'm going to try to, one thing I know I can replace is when I square stuff. Okay. So I'm going to square both sides. That's the technique I'm going to use to start it. The catch is when I square this side, it's the entire thing squared, which means that I am now foiling it. Okay, so I really am doing cosine x plus 1 times cosine x plus 1 equals sine squared x. Okay, so let's do some foiling, and then I'm also going to replace that sine squared at the same time. So what's cosine times cosine? Cosine squared, okay. Cosine squared x. All right, cosine x times 1. How many of those do I have? I've got 2, so couldn't I just write 2 cosine x? All right, what's 1 times 1? 1. Okay, we're going to work smart, not hard, and not make it 5 million steps. Okay. Sine squared, I want you to look up at the pink poster. Okay, so look up at your pink Pythagorean poster. I want you to find a replacement for sine squared and write it down right here. Don't call it out, but write it down. So everybody look up at the sign and write down what is sine squared equal to. You're looking for something with a cosine in it. Okay, what do we write? 1 minus cosine squared x. Good. Okay. If it's something quadratic like this, what does it have to be equal to solve? Good, 0. So I've got to move these guys. I'm going to choose to move them to the left. So how do I move the 1 to the left? Subtract. What happens? They cancel, so I don't really have anything there. It's technically a 0. Don't write it down. I'm going to leave it there as a placeholder so we don't. I'm going to erase in a second. Okay. How do I move the cosine over? Add it. So what is 1 cosine squared plus 1 cosine squared? 2 cosine squared. And then this just 2 cosine squared just drops down. And again, I'm going to get rid of the 0. Okay. And then we have equal to 0 on the right side. Okay. So we're factoring again. We no longer have a trinomial. Okay. Pencil. Okay. All right. What's the first thing we look for when we factor? Greatest common factor. Look at both of those terms that we have there, right? We've got this one and this one. All right. What is the same in both of them? 2 cosine x. Okay. So I'm going to pull out the 2 cosine x. All right. When I take 2 cosine x out of the yellow group, what's left behind? And out of the purple group, what's left? 1. All right. From there, I want you to finish it. Do zero product property. Finish it off. Okay. Check it with your table. Talk about it with your table. Everybody talk about it. Okay. In a minute, let's finish this. Let me finish this example, okay? All right. We are going to use zero product property, okay, and finish this off, okay? So what do I have to do with this 2? Divide it out, okay? So what is 0 divided by 2? 0. All right. Cosines the x. What were the x values equal to 0? Pi over 2 and 3 pi over 2. I like that we've converted into, we're done with degrees, right? They're dead to us now. It's just radians. All right. We're getting there. Next year, we don't do degrees at all. All right. What do I got to subtract that 1 over? Cosine again is the x value. Where's cosine equal to -1? Just pi. Good. All right. Shelly, do you want to go down while they're writing? Sorry. Okay, let's take a look at the next phase here. We're going to not use the graphing calculator ones. We're just going to get rid of that. The last ones we're going to do are these multiple angle ones. So it says that we're supposed to solve the multiple angle equation. We still have the domain 0 to 2 pi, where 2 pi is not included. Except it looks like on 24, they gave us a different domain, 0 to pi. So what multiple angle means is, do you see how all of a sudden now I have something in there with the variable on all of them? So we're going to tweak our last step just a little bit, okay? It's not any harder. It's just an extra step, okay? It's actually a pretty simple algebra with an extra step, okay? All right. So let's just do exactly what we've been doing and not worry about the 3t part, okay? So what do I need to do to move the 1 to the other side? Good. So we've got 2 cosine of 3t equals 1. All right. What am I going to do to move the 2 to the other side? Good. So cosine of 3t equals 1/2. Okay. So what we have been doing up to this point is we said, oh, t equals, and we just make a list of the two numbers, right? Or four numbers or whatever it is. This time, we're going to take whatever we have in here and we're going to set it equal to whatever those numbers are. So we might have 2 or 3 of those that we have, 4 of those that we have to write out depending upon what it looks like. Okay. So I'm going to say 3t equals, okay, and I'm going to find my radian measure. So where is, let's see, cosine's x value, where's the cosine equal to 1/2? Help me out with those two spots. We'll be okay with pi over 3, 5 pi over 3. So whatever's on the inside of the cosine or the sine, that gets set equal to your angle measures. Okay. Now I've got to isolate that variable t, right? How do I move this to the other side? Divide or multiply by the what? Reciprocal. So I'm going to multiply by 1/3 on actually both of these, right? So I get t equal to pi over 9 and t equal to 5 pi over 9. It was just one little extra tweak, right? Not a big deal. And that was our official I can statement, right? We were supposed to be solving multiple angle identities. That's something, this is the stuff that, it'll be that simple, but it will come up next year, okay? I'm not sure we'll see any of the factoring ones, but we'll definitely see something like that. All right, let's try it again together with number 24, okay? This one says it's just 0 to pi, so we don't need to go beyond the first half. All right, what are we going to do first with the 3? Subtract it. So I'm moving that 3 over by subtraction. So I've got tangent of x over 2 equals -3. Okay, what do we do with the 3 in front of the tangent? Divide it. Good. So you've got tangent of x over 2 equals, what's -3 divided by 3? Good. Okay. Tangent is what over what? Sine. I'm doing some scratch work off to the side here. Sine over cosine. I need it to be the same x and y value, but with opposite signs, right? So what is the value that's always the same? So square root of 2 over 2, right? I heard it. And so one has to be a plus and one has to be a minus, or it could be the opposite, right? That one minus, this one plus, all right? So find the ones that are the same, but with opposite signs, okay? Don't yell them out yet, but write them down after the equal signs. Okay, so I'll give you a minute to find it. Okay. What were the 2 radian measures? 7 pi over 4 and 3 pi over 4. I don't know why. It doesn't matter what order you do them in. I just happen to like putting the smaller one first. Okay. All right. We want to be careful. We do have a domain restriction, but let's go all the way to the end and make sure we're okay on the last line, because that other one could maybe make it so the last line, so it works. Okay. How do I get this 2 to the other side? Multiply. So I'm multiplying by 2. I should do that in a different color though. Let's go light blue. Maybe. So I'm multiplying by 2, multiplying by 2. So 2 goes into 4 how many times? So I've got 3 pi over 2. Okay. And we have 2 goes into 4 how many times? 2 again. So we've got x equals 7 pi over 2. All right. Oh, I'm looking at what I did last year. Let's not use this domain restriction because then we get no solutions. So get rid of that. I don't know why it's there. But I do need to stay in here. Okay, so let's use that domain restriction still. If I'm looking at my unit circle, is 3 pi over 2 on it? The bottom quadrant angle, is it there? Yeah, it's at the bottom quadrant angle, right? Where's my, how do I not have one in there? I thought I had a whole bunch of them in there. Apparently I didn't paste more in. So 3 pi over 2 is down here at the bottom, right? Is 7 pi over 2 on the unit circle? No, right? Because this is 4 pi over 2, 5, 6, 7 would be, it's coterminal with 3 pi over 2. So this one is out. This one would be our good answer. Okay. All right. Here's what I want you to try. Okay. I know we haven't done any secants today, but we did some secants yesterday. So you should be able to handle it. Okay. I want you to try both 25 and 26. I'm going to give you 3 or 4 minutes. Okay. To do both of them. Okay. With this multiple angle stuff. So everybody's trying those for me. Okay, let's check them together. So what is the reciprocal of, oh good, it did that, hang on. It's coming. Okay, what is the reciprocal of secant? Cosine. Okay, so I'm going to go cosine of 4x equals, what are we going to write on the right side? Good. All right, was cosine the x value or the y value? X. Okay, where is my x value equal to 1/2? What radian measures? Pi over 3 and what else? That one's been popular today, hasn't it? All right. How do I get the 4 to the other side? Multiply by what? 1/4. Good. All right. So we've got x equals pi over what? What's your denominator? 12. And x equals 5 pi over 12 again. Okay. Not so bad, I hope. All right. Tangent equals 1. All right, so I didn't even have to do any manipulation at the beginning, right? I just have to figure out where tangent is equal to 1. So what 2 radian measures did that happen at? Where's the first one? Pi over 4. Okay, where's the other one? Did we say 7 or 5? 7's over here, right? 5's over here. Which tangent's is be positive or negative there, right? Which would be make it positive. Okay, so this should be 5 pi over 4. All right, how do we move the 3 to the other side? Multiply, good. So you've got x equals 3 pi over 4. And let's see what's 5 times 3. 15. So x equals 15 pi over 4. Is 15 pi over 4 going to be on our unit circle? No. So it's just going to be 3 pi over 4 on that one. Okay. Okay. Those are the last ones we're going to do. I don't know why I photocopied the last page. I'm sorry. I killed a tree. I apologize. We're not going to mess with these. Okay. This one, believe it or not, doesn't factor. Guess what we would have had to use? Quadratic formula. So we don't need to do that. Okay. So we'll just deal with the factoring ones. Okay. All right. GimKit. Let's do that for a few minutes. Okay. To end it today, since it's Friday. Okay. Unless we're getting tired of GimKit. I don't know. You got to get your little skins. Oh, so I read yesterday. Okay. Whatchamacallit, that they're going to pause GimKit for the summer on earning the XP points. So you won't miss out on any skins after June 14th. Okay. Because I know some of you are playing this at home on your own because you're earning these skins. I know. Because guess what? That's what my son is doing. All right. We're looking at. Okay. I'm just doing unit circle practice. So we can always use more. All right. I know you all love Fishtopia. There it is. Get yourself in there. Let's practice for a few minutes, okay?